So this is a live demo unit of the H2OK innovation system. So we just have the sensor. This is usually what it looks like when it's installed on a pipe. So it actually makes zero contact with the fluid itself. It just attaches onto the outside of a flow cell. This is an off-the-shelf flow cell. You can use what you want. This one right here is what a lot of our customer factories prefer, which is a GEA Variant line, like a Tugendhagen Variant line Variant. But this can be a ferrule on the side of a tank, a tea that you like using, for example, or beyond. And so here, what it's reading is both the real-time reflectance and transmission of light as it passes through the process line or the fluid stream. So right here, this is an empty pipe, and you actually see this. Like, this is what an empty pipe looks like. This is the HMI screen at our edge gateway. So you see right here, this is what the empty pipe looks like. But different materials reflect and absorb different wavelengths of light because different materials are consisted of different molecules that all have different molecular structures, different atoms that are connected by different bonds that when you shine light and light hits these bonds, they vibrate differently. You might have a spring-like vibration, a seesaw vibration, or a rotational vibration at different frequencies. And that's why different materials with different quality, chemistry, composition, different types of fluids, different concentration will all reflect and absorb different wavelengths of light. And that's what we're capturing, a broadband fingerprint from the UV through visible to infrared. In other words, this is inline, real-time, low unit cost UV vis IR spectrophotometry. So this is what an empty pipe looks like. You see this reading here. And so I'm going to take this out and actually show. This is what a table looks like. And the coatings on the table and the table materials are different than this empty pipe. And that's why it has a unique fingerprint right here. You look at this Vizier, this top graph here. But you can also look, this is what my hand looks like. It's a different material, of course, different composition chemistry than this table, and that's why it's different. It changes the state. And this is what a metal plate looks like. It's a different material. Of course, a different chemistry and composition. And what's really interesting now is, let's just take some different use cases, right? If you want to look at product quality and changeover optimization, we actually have just two different off-the-shelf beers. And you can see the differences. Like if you're doing a changeover, you stop production of this one product, you water push, and then you start production of a new product. So you want to know, when do I fully push out my previous product in my changeover? When do I hit 100% water? Instantly feedback, start pushing the next product. When do we reach 100% good quality in my next batch? When can I send this to the filler instead of sending this to waste to reduce product loss and improve efficiency, line efficiency? And so I'm going to just put this, in this testing unit here. I'm gonna just screw this on. Imagine this just being, similar to a product flowing through. So I'll put this on, and then this side. Right here. This other side. So we just put the sensors onto the sample holder. Imagine this is a pipe with product flowing through. So I just have one variant of beer. You see, this is what the fingerprint of that beer, good quality, off the shelf, looks like. Then now I'm going to baseline it to compare different products. I'm just creating two different types of beer, for example. So you have this beer, you finish producing this batch, then you push with water. You want to figure out when do you reach a clean state, when do we reach fully water? That's the difference between beer 1 and water. So check the difference between beer water in a changeover process, for example. And then we're gonna start pushing this beer. When do we reach good quality for this new beer that we're creating in this changeover? You see, that is the difference between beer 1 and beer 2 that the H2OK system is detecting. And so now you can be able to automatically transition into when you reach fully water and your water push into your next beer, you reach a good quality, it detects that, communicates with the PLC, and then sends this to the filler instead of sending this to waste, improving product quality to make sure we're not batching bad quality, but also reducing product loss. Now, let's put this to the test as well. You can look at different products. So for example, this is tea, different material. That's the difference between, this is the difference between beer 1 and tea. Now what's really interesting is, you can even put this to test even further. These are two of the same body wash in a FMCG, like personal care company, two different fragrances. And so when we're doing a changeover, for example, we stop making this first fragrance body wash. It's made from the same common base material. So you're pushing this common material, and then you start dosing this new fragrance, and all of this product goes to waste. So the common base that's in between, and also the timer that's set on the new batch, the new fragrance that we're dosing, that also is sent to waste until it finishes that time, and then we send that to the filler to allow for stabilization traditionally. So what we can do is we can distinguish the difference between two of the same products, different fragrances, to see in real time, okay, we're reaching good quality of this new batch, this new product. We can send this to the filler instead of sending this to waste, reducing our waste and also our product loss and improving line efficiency. So I'll actually show you, if we can clear that baseline. This is what this first variant of, this first fragrance, this first variant of body wash looks like. I set that as a baseline. Now I'm putting the second variant. So that's the difference between the two products with different fragrances. This is a live demo of the HOK innovation system.